Welcome, everyone. My name is Brian Goebel, and I'm a Territory Sales Manager here at DoubleRadius. Thanks for taking the time to join us today as we host Cambium Networks for a webinar on how cnMedusa advances WISP networks. Joining us today to make our presentation is Matt Mangriotis, Product Manager at Cambium. We'll also hear from Jay Stewart, the Assistant Manager of Plant Operations for Giant Communications. Jay will be sharing with us how his company is using cnMedusa in their network. And before we get started, just a couple of housekeeping items to go over. Number one, if you have any questions throughout the presentation, please enter them into the questions box so we can get them answered, and we'll have a Q&A session at the end. And lastly, when the webinar is over, please take a minute to provide your feedback on our quick survey. And with that, let's jump right in. I'll hand it over to Matt now to get us started.
Good morning. This is Matt Mangriotis. Thanks for the introduction, Brian. I'm happy to be here from Cambium on behalf of DoubleRadius to present to you guys a little bit about Medusa. We're going to go into some technical details around the frame and how it really works in order to bring that performance that that people are loving in their networks. And then we'll talk to Jay about how he's actually using it in the real world and how it's performing. So without further ado, let's get into it. So Cambium, I'm going to go a little bit in detail about the history of Cambium, just to bring you up to speed. If you're not familiar, I'm assuming most folks that are attending this or have signed up for this webinar are familiar with Cambium, but we are a point-to-point and point-to-multipoint industry-leading provider of broadband equipment. We're focused on everything wireless. We recently went public last year. Almost 1 year, 10 days from now, it'll be 1 year that we went public on the NASDAQ. So you can follow our stock, which isn't doing too great, but we're business is good. So we're pretty happy about the direction that we're headed as a company. Again, focus on everything wireless, headquartered outside of Chicago. That's where I'm at. And we have lots of employees doing lots of cool things around the globe, all kinds of different countries and all kinds of different nodes around the world. But what do we really do? We provide wireless solutions for just about every aspect of a wireless network, from microwave long distance links to the access layer networks, point to multipoint, kind of the hub and spoke type of deployments, which is where the 450 sits. We have industrial IoT solutions for all kinds of different vertical markets, including offshore, oil and gas, wastewater management, all of the utilities that are out there. We have hardened industrial solutions for that. Access layer networks for Wi-Fi offload, including an extensive Wi-Fi portfolio now with the CN Pilot and Xeris lineups. So all kinds of really great solutions for anything wireless, end-to-end wireless connectivity. And all of that is managed by our overarching network management system called CN Maestro, which is a great kind of one pane of glass tool to manage all of the aspects of your network. So let's focus a little bit on the 450 platform today. It is the flagship point-to-multipoint platform that grew out of the Canopy platform from way back in the day. That product came out of Motorola back in the early 2000s and really grew the WISP industry, the wireless internet service provider industry, from nothing to what it is today. And this product, the 450 platform, really came out of that Canopy design. It started as frequency shift keying, which is a type of protocol methodology, and we've moved to OFDM MIMO, and now with Medusa, multi-user MIMO, and we'll get into some great details around why that's important. The beauty of this platform is that it's a software-defined radio design. It really allows us to do just about anything to the protocol, to even down to the physical layer. We can change things at will. We have an RF baseband chip and an FPGA, which means everything is written in software. That means it's proprietary. It's not a standards-based protocol, but we can emulate standards-based where it suits us, and we can deviate from standards-based solutions where that does better for performance standpoint. One of the hallmarks is GPS synchronization, which always has been a hallmark of the platform, in order to maximize the spectral efficiency, which is a key parameter in any network, especially those that rely on unlicensed spectrums, where spectrum is really scarce. And we'll talk about some of the aspects of that as well. We evolve the platform, and I'll explain how we do that in just a moment. As far as applications go, use cases, our typical use case, our typical deployment strategy is an access point, what we call a fixed wireless access point or a base station at a given high site location typically. And that connects wirelessly to a subscriber module or a customer premise equipment module on a home. That's our typical deployment. Very simple, very flat architecture. No EPCs, no core networks to worry about. You connect that base station directly to your network at any point in time, and you're off and running. We can complement this network with an indoor Wi-Fi router and so forth, and that's what a lot of our customers choose to do. And it's a great, simple solution for that residential broadband access market. Another really popular application is wireless video surveillance applications. Being that we're a proprietary protocol, our frame structure is very flexible, so we can tune it to have a substantial uplink presence if necessary, which is ideally suited for video surveillance applications. So really, it can be a complete wireless solution for mission critical uplink and high uplink bandwidth. You can connect the camera directly to the auxiliary port on our 450i radios to upload that data from the cameras at a really reasonable rate. So that's another popular application. And further, carrier and Wi-Fi offload from mobile networks is very, very popular in more dense areas, suburban, multi-dwelling units, campus type environments. That's another common application for the 450 platform as well. I do want to mention here CBRS. So we're not going to go into great detail on this topic today. That's a whole bunch of information around CBRS itself. I will summarize in a couple of seconds that Cambium does have the industry-leading platform supporting CBRS today. It is certainly the most devices that are in operation in Part 96 of any vendor or any application for that matter. The fixed wireless application for CBRS is by far the most popular. There's a lot of hype around private LTE, neutral host, all the cool things that CBRS will bring to the table. Well, folks in fixed wireless are using this right now and using it effectively. It's extra spectrum, 100 megahertz of extra spectrum over what was offered in Part 90, and it's being deployed today. The 450 platform supports it with every piece of hardware from 450 to 450i to 450M and now 450B, and we'll talk about what those things are. But we support all of that in Part 96 as well under CBRS. So keep that in mind as you think about potentially using this spectrum going forward. We partner with all the major SaaS providers federated in Google today. CommScope in about a month and a half, we'll be ready with CommScope as well. And keep in mind that in October, come October, most of the licenses, the Part 90 NN licenses will expire. So if you are operating in 365 today, make sure you check your license expiration date and be ready for this transition. A lot of folks are doing it now, but there are a fair number of folks that have not explored this yet and need to think about it before October. So that's all I'm going to say on CBRS, unless we have some more comments or questions later. So the platform evolves. I mentioned it's a software-defined platform, and we go from the original 450 access point on the left. We've integrated the newer next-gen hardware in the middle there with the 450i to a nice sector antenna that we designed. And then now we have the 450 Medusa product. On the subscriber side, you can go across the board on the top where we had the original candy bar form factor, which looked a lot like the PMP 100. And we've moved and evolved that to the next gen, which is the bottom row there, and released the 450Is, which are kind of the integrated ruggedized versions. And then the 450Bs, which are higher performing and lower cost. We have a mid-gain and a high-gain version. I mentioned DPS synchronization. I won't say too much about it other than the fact that it really allows you to be able to reuse frequencies because everything transmits at once and then turns around and receives at once because we have a TDD system, a TDMA type of frame architecture. This allows you to reuse frequencies across your network in a nice pattern, which enhances the spectral efficiency, the ability to use that given spectrum that's available. All of those things lead, I won't read through this slide directly, but all those things lead to the highest throughput and system capacity that we can offer. It keeps the latency low. It's a deterministic channel access, meaning that the SMs are only requesting bandwidth when they need it. We're not polling. It's not a system like Wi-Fi or 802.11 where it needs to constantly poll to see if there's available slots. It's only mapping slots to subscribers that request bandwidth. So it is a completely deterministic frame. And I'm touching on some of the aspects that we'll go into a little more detail, which will help you understand why this 450 Medusa solution is so good. And again, another point to the fact that we continually evolve this platform. We never leave things in the dust. We never leave things behind. We're compatible with all the way back to the first generation of 450 products, but we continue to evolve and enhance performance of everything in the network. So that brings us kind of to the Medusa product. We also call it 450M or cnMedusa, Cambium Networks Medusa product. It is encompassing the massive multi-user MIMO technology. In the 5 GHz device, it's a 14 by 14 antenna array, which means it has 7 dual pole transceivers in it and an extensive beamforming antenna array attached to that. It's all integrated, very simple to install, but in this slide, it says it can achieve 400 megs in a 20 meg channel. We've seen it actually hit about 900 megs in a 20 meg channel in the lab scenario. So this slide was created a while back and clearly needs to be updated. But this technology brings a whole lot to the table, and we'll go again into detail around the frame structure and why that is. We've also released this in the 3 gig space. And as I mentioned, CBRS compatibility, which means this is future-proof, if you will, for the US-based market, in that it can operate under Part 90 or Part 96. It can transition between them via software. In the 3 gig space, it's a little bit taller of a product, a little bit beefier, a little bit heavier, but the same integrated, simple solution. And it's an 8x8 solution versus a 14x14. Reason being, if we were to do a 14x14, because it's a lower frequency product, the antenna elements would need to be larger and spaced apart further due to physics. And it would have been a very cumbersome and tough to deal with product if we were to do a 14x14. So we scaled back a little bit, did an 8x8, fit it in the same similar footprint, such that it would be cost effective and able to put out there. So it's been out for a while. It's been out for a few years now, and it's all over the place, all over the globe. These are snapshots from various locations on the Earth. The bottom left is Moscow. I think the bottom right is somewhere in Arizona. But clearly it has applications everywhere where we need to enhance capacity and spectral efficiency. I do like to point out one case study, if you will, or an example of where this is very, very effective. We have an operator in Italy. The name of this operator is Iolo, and they've been using 450 since it came out pretty much. And in 2017, before they had Medusa really widely utilized in their network, they appeared on the Netflix speed index for the country, which is pretty impressive in and of itself. They were the top wireless carrier. You can see the icons there indicating the type of connections that were made. But since then, they've deployed Medusa extensively, and all they use in their network is the 450 product. And now they're the only wireless in the top 7, and they're number 1. They have been number 1 for quite some time. If you look at Netflix stopped reporting this, by the way, due to kind of the COVID concerns around the globe. But as in January, they were number 1 still, and had led most of 2019. And it's very impressive that they are able to do this with the entire network being mostly the 450 product. And due to COVID, they've seen a spike in their network, but the 450 platform has been pretty resilient, and even with a spike in traffic, average traffic of about 60%, it's holding up well. Was a testament to the ability for this product to scale. They have hundreds of thousands of subscribers across the entire country of Italy and are providing the best service per Netflix. So it's pretty impressive stuff. Let's go back in history a little bit. I just want to show you, this is the first Medusa. We connected 7 650 radios together way back in 2014, and then connected them all to an antenna array. We were starting to experiment with beamforming and the antenna design. And you can see that we actually put it outside and tried some of this way back when. Since then, things have evolved. It's all about the antenna design and antenna excellence moving forward. We started with a simple device, a 4x2 that you may recognize this as EPMP 1000, the integrated unit. We moved to the EPMP Force 180 and the 450B. We did some beamforming in the receive with the EPMP 2000 beamforming antenna. And then we've done our sector antenna, our integrated sector antenna design. And combining those two things, we really add some other aspects of antenna design, including what we call Null Fill. Null Fill helps make sure that there's signal levels in the nulls when you're close to the antenna deployment. So if you're up 200 feet on a tower pointing 8 to 10 miles away, if you have a customer or a subscriber that's close by, maybe 100 yards out from that tower, if they're too far below the elevation pattern, they won't get any signal. But we've added elements to tune that signal so there is signal down there, and we can do that. A lot of antenna manufacturers kind of skip this important aspect. We also talk about integrated electrical down tilt to make sure that we're making contact with those subscribers of interest. So that's kind of a little bit on antenna evolution. Now let's talk about the frame. So Medusa, the way all 450 works actually, is a TDD system, and the basic frame is 2.5 milliseconds or 5 milliseconds, depending on how you set it. It's flexible, and that frame is split between downlink and uplink, and split in any way that you choose. You can adjust the duty cycle to be more heavy in the downlink, therefore more of that 2.5 millisecond frame is in the downlink and less is in the uplink, which is typical for residential deployments. Or you can change it to be the other way. Now the TDD frame works as such. There's several different steps, and we'll walk through each step so you can see what the product is doing at any given point in time and why this is so important. So at the beginning of the frame, there's these control symbols that go out. What this means is we're sending beacons. We're discovering where subscribers are. We're setting up the gain from those SMs. So the gain on the SM side is automatic transmit power control, which means the products will not overpower the access point with unnecessary power. If it's close to the AP, the SMs will actually set their power lower. And it does this by doing some of this AGC symbols that come out of the access point at the beginning of the frame. So there's lots of different things going on at the beginning to gather information about all the things that are happening in that sector. Then the sector goes into what we call sounding, and the sounding parameters, all the subscribers are now telling the access point where they are, spatial frequencies, so that they can be grouped together. So one of the aspects of multi-user MIMO is such that the access point knows where in the azimuth or where across that 90-degree sector all these subscribers are located. And because of that, he can actually group certain ones together and talk to them at the same point in time. Multi-user MIMO means I'm talking to more than one subscriber at once. And I do this via beamforming and because I have this sounding information. So in this part of the frame, the access point is actually determining where all those subscribers are at and determining whether they're eligible to be grouped. Then we do downlink unicast, and what that means is I'm doing a sector mode. I'm doing the whole 90-degree sector in sector mode, and I'm doing that mainly due to high priority SMs. So if I have an SM that really needs data first, like a VoIP channel or something, I'll do that first before I do the multi-user MIMO. I can also do this in beamforming mode, where my access point can beamform to a specific subscriber. And usually, again, that's non-MU-MIMO eligible SMs or high priority SMs that are getting that. And the beamforming does a couple of different things, just to touch on what beamforming can do for you. It's about not only directionalizing that antenna gain, which pushes the antenna gain farther, it also reduces interference. By narrowing that beam, I'm reducing both the receive and the transmit beam width, thereby ignoring more that's coming outside that beam width. So if you see I'm pointed at the SM that's towards the top of the graph on the right side, I'm not listening from the guy who's the red dot anymore. Whereas in sector mode, and on the left side, I have that red guy that's within my tolerance of listening or my receive beam width. And so that could be affecting my uplink signal. So beamforming does a lot of different things. It points that energy towards a specific subscriber of interest and eliminates noise from elsewhere. This occurs on Medusa in both the downlink and the uplink. So it's a very important aspect of the operation. So now that I know I have beamforming, I know which products can be grouped or which SMs can be grouped together. I can do what they call multi-user beamforming mode, multi-user MIMO. And that means I'm talking to more than one subscriber at once. And this can be done in a number of ways, up to, in the 5 gig band, up to 7 at once. And effectively, that can mean at some point in time, I can do up to 7x the amount of throughput in the same frequency space. Meaning in that 20 megahertz channel, I no longer am limited to about 250 megs. I can go up, up to, as I mentioned, about 900 megs if the conditions are ideal. If all of them have valid spatial frequencies, if they require data to be sent, and they're all separated by at least about 6 degrees in the azimuth. So I mentioned spatial frequency a couple times, and really that's the radio, the AP, which is at the bottom of the graph here, knowing where across that sector those subscribers are. It's a number that's transmitted in that sounding data that's tells the access point where those subscribers are in order to group them together. Then I finish up the transmit portion of the frame, the downlink. With any spare symbols that I have, I can transmit with either sector or beamforming mode. So I don't waste any time in the frame. I'm doing everything I can to transmit as much data as possible. Then we turn around and do uplink. And in the uplink, we have beamforming mode, and we have it in unicast first. And what beamforming mode in the uplink does for you is quite substantial. When we released Medusa, we saw jumps in modulation just about every SM that is out there because we increased the sensitivity. Beamforming in the uplink really helps because typically at the base station side or the AP side is where you have the most potential for interference because there's usually a lot of radios on that tower or in that water tower space, the high site, whatever high site you're using. Typically you have more than one radio there. And so the uplink beamforming really helps to eliminate that interference. Then we turn around and do MU-MIMO in the uplink. So we can not only do MU-MIMO in the transmit with the Medusa, but we can do it in the receive. This is a huge benefit for uplink capacity, including applications like video surveillance. Just want to point out here, none of the standards today support this currently. Now 802.11ax and 5G-NR, they will support multi-user MIMO in the uplink, but they don't yet. And it's pretty impressive the things that we're doing and have been doing for a couple of years now with this product, well beyond what the standards-based stuff does. So I mentioned here's a lab scenario where I'm in a 20 meg channel and I've got 900 aggregate throughput that you can see up at the top, about 600 down, 320 up, for about 45 bits per second per hertz of spectral efficiency. Very, very impressive stuff. In the 3 gig, we can get about 500 megs in the same 20 megahertz channel. Now, again, these are lab scenarios, ideal conditions. You probably won't see things like this in the field. but you can come darn close, and we'll see some of the actual field data in just a minute. But this is showing here we're grouping 4 subscribers at a time, 100% of the time. There's a lot of statistics available in the software that can help you hone in, optimize the scenarios, understand what is going on in your network, and tune it such that you can get the most out of these products. Then we go back to finish up the frame. We have what we call contention slots. We mentioned before that there's it's a deterministic frame structure. In these contention slots, the radios are, the AP is listening in these mini sectors. It's beamforming, so it can actually receive more than one contention slot at once, thereby taking up less of the frame time to identify where the transmissions need to go in the next frame. Very, very cool stuff, and very effective. I have a little animation just kind of walking through all the various frame structure pieces, and knowing that this occurs at a rapid rate. It's not just, it's only 2.5 milliseconds long. So this actual, all of these steps occur 400 times per second. So you can kind of see how it's getting faster and faster, and see all of the various things that go on during this frame. And again, we can operate in 2.5 or 5 millisecond frames. The 5 millisecond frames is important because we can also co-locate with other vendor equipment where necessary. It is, we have frame calculators that can help you co-locate with LTE equipment, especially in the 3 gig space where we see a lot more of that stuff. We do have a white paper online that talks about all of the technologies that I kind of covered very briefly. It's not a science paper as such. It's not a real white paper. It's more of a solution paper talking about all these various things and why they're beneficial. And I encourage you to go to the Cambium website and download this paper. It's not super long, it's not super technical, but it does go into some detail like I did here around the frame and how it works. And at this point, I kind of want to introduce Jay of Giant Communications. Yeah, he said yesterday, I said, "What's your title?" He said, "I am a man of many hats." As a lot of you guys in the WISP industry do, you have to do a lot of different things to keep your business running, and then Jay is one of these guys. So Jay, are you there?
I am. I'm here.
I would love if you would like to explain a little bit about how Medusa is working in your network and how you've employed it.
Sure. Good morning or afternoon, wherever you are. Let's take a trip back a little over 10 years ago when Motorola came out with the PMP320. We invested in it on 3 sites. We didn't think it was going to morph into the amount of subscribers that we have today. We were kind of figuring about 100 per site. Well, it ended up morphing to about 600 customers total on these 3 sites that we deployed the PMP320 on. As you know, come October, the PMP320 or any of the Part 90 equipment, of course, isn't going to be acceptable to the FCC anymore. So 2 years ago, we started migrating our PMP320 customer base over to the PMP450 5 gig. Basically just taking our line of sight or very near line of sight customers, peeling them off the 320 platform and putting them on the 5 gig platform. We were able to, migrate fairly close to about 400 of our subscriber base to that. The other 200 I'm going to classify as near line of sight or non-line of sight. And this year we're aggressively working towards the 3 gig Medusa, trying to migrate those customers as well. It's working very, very well, to tell you the truth. And in fact, if you want to go to my next slide here, we always enjoy Cambium teasing us with the lab data, but here is some real field data. Here's a 5 gig Medusa, 42 customers on a 20 megahertz channel, and we're able to do an aggregate of plus 500 megs. These customers, they range from 1 mile to about 10 miles. We're cutting off our 5/8, at about 12 miles today. So we're continuing to take those subscribers that don't have line of sight or non-line of sight, onto the 3 gig, and we're seeing, an improvement out in the field with the higher EIRP of the Medusa. We're seeing a difference between probably 5 to 6 dB on the level, between the 320 and the 3 gig Medusa. We still have quite a bit of work to do. The 3 gig Medusa, it's a little different animal than the 5 gig, with it being you have to have negative 48 volts up the tower, and it's not a PoE type product. But we've worked through that, and we actually feel with the 3 gig Medusa, it feels a little bit more carrier grade with that power requirement on it. So we've loaded up our cabinets with battery backups, DC plant, and we're going to try and go into the 21st century here doing it right.
Sounds real good, Jay. And I guess I'll turn it back over to Brian and the DoubleRadius team, and they can, if we have any questions that have come in, Jay and I can answer them if possible. Brian, do we have any questions?
Yes, actually, we do have a couple. But at this time, also for everybody else that's listening in, still this is now a good time to enter in any more questions that you might have into the box, and we'll try to address as many as we can. But for right now, so far, Matt, the first question relates to CBRS, but they're asking, will the 450i and the 450m support channel bonding with CBRS?
So we do have plans in the roadmap to do that, and we're talking about late 2021 to be able to support that. We also don't really believe that you're going to really need that for quite some time. In CBRS, the channel plan as it stands today is that it's 150 megahertz broken into 15 10 meg channels. The PAL auctions are kind of in process. You had to submit your intent to pursue those by May 7th, and the auction will start late July. And we're expecting to see what happens, I guess, in those PAL auctions. We have the kind of the list of people who are intending to bid. We'll see how those play out. The only scenario where channel bonding or channel aggregation is really of concern is the scenario where somebody owns a 10 meg channel of the PAL and may be separated from the GAA spectrum that's available in the area by some amount, such that they require 10 megs of the PAL and 10 megs of GAA that are separated, or replace 10 megs with however much spectrum you want to use. That's really the only scenario where channel aggregation becomes absolutely necessary. And if folks don't own PALs, then it's nothing really to worry about because we're working with all the SAS vendors and SAS administrators to ensure that if you're using GAA and you're requesting 20 meg and there's 20 meg available, they'll shift things around in most cases to be able to put those 20 megs together, make it contiguous. So it's not as big a worry unless you own a PAL and only own one PAL, or only own less PALs than required to deliver your service. So less important perhaps than some folks are making it out to be, but still we are working on implementing channel aggregation type of solution with the 450 platform for late 2021. Long-winded answer to your question, but hope it was comprehensive.
Okay, thanks, Matt. And the next question that came up during the presentation was, and I think you actually addressed part of it, but how many beamforming customers can be turned on at the same time, and then how does it affect others in the same sector?
So the way the system works, and maybe I should have been a little more clear about this at the beginning, but the multi-point system, the access point, whether it's 450, 450i, or Medusa, can support up to 238 subscribers per sector at once. And this is regardless of the mode of operation that it's in. Beamforming occurs with Medusa in a multi-user MIMO fashion, and it's only occurs when, pardon the phone, sorry about that. It only occurs when it's the beamforming is up to 7 subscribers at once in the 5 gig band, and up to 4 subscribers at once. It does not affect the operation of any other piece of the sector, but it's talking to those 7 at once, and then it flips and talks to another group by the TDD slots. So it in a TDD system, you're talking to one, then the other sequentially. But in sector mode, your antenna pattern is spread throughout that 90-degree sector. Whereas in beamforming mode, you're narrowing the sector and talking to one specific subscriber. And we can do that to more than one subscriber at once, and then shift those beam patterns in the next time slot. So it's not adversely affecting the way that it operates in TDD mode, but it's enhancing that with multi-user MIMO. I'm not sure if I was very clear on that, and I like to have pictures and whiteboards when I'm explaining that, but
yeah, and I'm going to help back Matt up. I'm going to help back Matt up here. You know, in a perfect world, yeah, we should see 7 simultaneous streams. In a real world, or where we have this deployed today, just at least on our sites, we're seeing an average of about 4 to 5 groupings, you know, within the AP. Just depends on how congested the AP is and how you know, geographic your subscribers are.
Right, and whether they need data transmitted. So some may be idle, whereas if you had data requirements for all of them, their grouping may go up even. Any other questions?
Actually, this question actually came up for Jay. They're asking, what subscriber module are you using currently with your 450M 3 gig APs?
We usually we carry a lot of the high gains on our floor. I mean, I'm located in Kansas. We don't have mountains, but we have nice rolling hills and some foliage. But my flavor, just on the 5.8 itself, you know, unless it's really line of sight, we'll stay with the high gain antenna and just use the mid gain appropriately.
All right, and then there's another question that came in about how far out do you set your 3 gig 450 APs? I'm assuming I'm not exactly sure exactly what they mean by that, but how far?
There's so many scenarios out there. You know, within our working scenario, and I'm sure Matt has some other ones, but within our working scenario with our competitors and how we have to sync in time with each other, we're doing ours at 15 miles.
I mean,
okay.
we hear, just to give some color to that, we hear from various customers and operators that the 5 gig range, you know, as Jay mentioned, he does up to 10 miles. We hear that limiting it to 6 or less is even better, thereby keeping most of your guys in higher modulations. And then with the 3 gig, you can go farther, but there's also the near and non-line of sight considerations. So if you're trying to punch through things, it's going to be more difficult, and you want to scale back that range to make sure that you're achieving the best modulations that you can in order to take best advantage of the spectrum you have available.
Yeah, and we've definitely went back after we've loaded up an AP. We may have set it at 15 miles to begin with, and we've you know, reconstructed the configuration and noticed, you know, some of the SMs aren't even touching 15 miles, and things are below 12 miles. So we'll go ahead and back it down, you know, after that reconfiguration.
Okay, and then we did have another question. How does Cambium work with Preseam?
It absolutely works well. I would encourage you guys to go download the latest Preseam report. They publish a report. I think they try to do it quarterly, but there was a recent one from Q1 of this year. And you can see in that report how the Medusa stacks up against everything else that's out there. They have a population of hundreds of thousands of units throughout mostly North America, mostly US and Canada, that they talk about, all the various aspects of network performance, including how many how many SMs are connected to each AP, how much throughput is going through. And they do a very good job of explaining why those things are important. And you can see just from a few of those graphs how well the Medusa stacks up against the competition, or how it outperforms. It's a very obvious distinction in the graphs. But yes, absolutely, we work with Preseam.
Okay, and then we did have one last question so far. They're asking, I guess it was in one of the previous questions there, but they're asking basically what speeds are we seeing at those distances that you were talking about, Jay, from the APs to the subscribers, like on average?
We run 3 packages right now: 10 by 2, 25 by 5, and 5010. Of course, the 5010 needs to be a little bit more qualified, than a 10 by 2 or 25 by 5. We definitely are liking the new CNN Heat that's out there. That helps us make certain assumptions, at least behind our desk, on what that customer could truly get. So those are the 3 packages that we're offering today.
All right, I think that's all the questions that we have at this time. So I guess we'll just go ahead and wrap it up. But I just wanted to make sure before we close out for everybody, please take a minute to fill out the survey that's going to pop up on your screen. We certainly appreciate anybody's feedback. And I want to thank everybody again for joining us today. Stay safe, and we'll see you next time.
Thanks very much.
Thank you.